Okay, so in the last class, I gave you a question. Have you done it? All of you? No? You tried? Did you try? Okay. So it was that we have an ellipse and a hyperbola, and they have the same focus. So the curves which have the same focus are known as confocal. This we discussed last time. So they are confocal and they have the same length of minor axis. So the value of B here is same. So here this is B, this is also B. Instead of A1, here we have A2. And similarly their eccentricities will differ. So let's say eccentricity is E1 and E2. So what was the question? Yeah. So can you try it now? Now see, the hint is if they are confocal, if they have the same focus, let's say these are the two foci. Okay. Then A1 E1 will be equal to A2 E2. This is clear to everyone, right? So in the case of ellipse, the focus is given by A1 E1, comma 0, and similarly minus A1 E1, comma 0, and this one will be A2 E2, comma 0, because this is also the focus for the hyperbola. So therefore, we have A1 E1 is equal to A2 E2. So this is the first relation, right? The value of V is same for both of them, right? What other relation we have? Yes? We have a relation for eccentricities of both. Yeah, what is the value of E1? Ellipse. So in the case of ellipse, the eccentricity is square root of 1 minus b square upon a square. So this is 1 minus b square upon a square, a1 square, right? And this will be e2 is equal to square root of 1 plus a2 square, right? So now you need to define a relationship between e1 and e2. Can you try now? Do it. So from here, from the second equation, we know that b square is same in both the cases, right? What we can do is, we can see the value of b square from both of them. What is the value of b square from here? a1 a1 into 1 minus e square. Is this correct? Right? What is the value of b square in case of, this is in the case of ellipse. What is the value of b square in the case of hyperbola? Will it be plus? This will be plus and this will be minus. So this will be a2 square, right? So a2 square, e2 square minus 1. Okay. We also know that a1 e1 square, a1 square e1 square is equal to a2 square e2 square, right? Try to do it now. Do you understand this part? This is a standard formula, right? B square is equal to A1 square 1 plus E1 square. Will it be minus? Let's see. Let's calculate. If we square both sides, we get E1 square is equal to 1 minus B square upon A1 square. We move it this side, we get B square is equal to 1 minus E1 square into A1 square. Yeah, it will be minus. And in this case, is this correct? So in this case, we have E2 square is equal to 1 plus B square upon A square. Yeah, this is correct. So this will be E2 square minus 1. So in both the cases, we have 1 minus, right? But in the case of ellipse, we have A1 square, 1 minus E1 square, and this is E2 square minus 1. What's the next step? Anyone? We have two relations now. First relation is this one, that A1 E1 is equal to A2 E2. And next we have these two relations. What should we do? We need a relation between E1 and E2. So I need to eliminate all the unnecessary variables like B, A1 and A2. How can you do that? And then? So we have two equations now. First we have these things, right? And then we have this. So from here we get A1 square upon A2 square is equal to what? A2 square upon E1 square. Why did I take the ratio of A1 upon A2? Because I can get the similar ratio from here. Can you see this? So if you equate these two, you will get A1 square 1 minus E1 square is equal to A2 square E2 square minus 1. Okay. So if you calculate the value of A1 square upon A2 square, this is E2 square minus 1 upon 1 minus E1 square, and this is also equal to E2 square upon E1 square. Okay. Now we eliminated all the variables. We got rid of B, right? We got rid of A1 and A2. We're just left with this relation. Cross multiply, you are getting E1 square E2 square minus E1 square is equal to E2 square minus E2 square. So this will go this side. It will become twice. So final relation is E1 square plus E2 square is equal to 2 or 1 upon E1 square plus 1 upon E2 square is equal to 2. If you divide the whole side by this equation, you will get 1 upon E2 square plus 1 upon E1 square is equal to 2. It's the same thing. Understood? Right? We saw a similar relation in the last class. Do you remember? Where? Without looking back. Yeah. In the case of hyperbola and its conjugate. So whenever we have both the hyperbolas, we are getting 1 upon E1 square plus 1 upon E2 square is equal to 1. In this case, we are getting 1 upon E1 square plus 1 upon E2 square is equal to 2. Got this? Have you written? So the next question is, find the locus of the center of the circle that touches the two given circles. So this is a representation of a circle with the center C1 and the radius R1. And this is having center C2 and radius R2. So you need to find the locus of the center of this circle. So first of all, draw a figure. Okay. This is a given circle. This is touching two circles externally. So first circle goes like this, and this is second. This is R. Okay. This is H comma K. This is also R, and this is R2, and this one is R1. Okay. This is C1, this is C2, and this is C. So you have to find the locus of point C. So what do we do in locus? Do you remember? Will always be these 2 points. No, this is variable circle, right? Whenever we study locus, we take this, you need to find the locus of the center of the circle. This circle is variable, this is varying, right? This might be touching right now over here, then it might be touching like here, okay? You have to judge the movement of the center. That what is the movement of the center becoming? That's why we study locus. Path traced by a moving body, right? Path traced by a moving point of the moving body. So whenever this circle is moving, you have to tell me what is the shape of the path formed. So this circle will be touching these two circles at different points, right? It can touch like this. It can be a bigger circle and touching like this. I've just taken this one case, okay? So I'm given with C1 R1 and C2 R2. I assumed one extra thing here, which is R, right? I need to eliminate this thing now. In order to find the locus, we take arbitrary constants first, and then we try to eliminate them. That's what we do, right? So what is the distance between C1 and C2? This is they're not equal. This is R, this is R1, right? So this is a variable circle. This center is C, and this radius is R, which I assumed. Okay. So what is the distance between C and C1? So C1 will be equal to R1 plus R, or R plus R1, same thing. What is the distance between C and C2? R plus R2. What can you do now? So you will subtract these two equations. Why? We have to eliminate this R, right? So we get C1 minus C2 is equal to. So this is the locus of the point C. So can you judge now? What will be the locus? What will be the curve formed? Now here we have two fixed points which are C1 and C2. The distance of this point C from these two fixed points, the difference of the distance is constant, is always constant. Since this radii are always constant, these are two fixed circles, two given circles, right? This is the variable circle, this C, right? So whenever we have the difference of two distances constant, this is known as a hyperbola. You remember? And these two fixed points will be foci. We studied this last time, remember? So we studied this property that whenever we have a hyperbola, the distance from the two foci, right, that S1P minus S2P, this is always equal to 2a. Can you recall this? Right? So S1P minus S2P is always equal to 2a. Okay. So similarly here, this is the moving point P, because we have to find the locus of C. So this will be the moving point. Its distance from C1 and C2, right? The difference of the distances is equal to R1 minus R2. So we can judge from here that the distance between the two foci will be equal to C1, C2. Here the two foci will be C1 and C2. Why? Because these are two fixed points from where I'm measuring the distance, right? Similarly, in the case of ellipse, we had the sum of the distances from the two fixed points is equal to 2a. In the case of hyperbola, we have this. Okay. Understood this part? Right? So write this down. So here we'll have the foci C1 and C2, and the value of 2a will be equal to R1 minus. Okay. Anybody having doubts? Okay. So I'll give you a similar question. Find the locus of center of circle touching one given circle C1 R1 internally and other C2 R2 externally. Try this. It's quite similar. Hyperbola. How?
Touching the circle internally.
Okay.
R1. This distance will be R minus R1. Only R.
Why?
in this circle.
Mm-hmm.
So this will be only R.
Where is C1? C1 will be the center of the circle, right? This one.
So this one.
Yeah. So,
R1 is this.
okay. C.
C and R. So it will be
Okay.
ellipse because sum is
Whose sum?
this will be R plus R2
Hmm.
and this will be R minus R1.
Okay.
So we will subtract these two equations.
So we are subtracting, right?
Negative sign will come and difference here.
So we are getting difference. This will be hyperbola. Right. So this will again be a hyperbola or an ellipse. What? Hyperbola. So we're getting two circles, two fixed circles, and one variable circle. Okay. So this will be the center, let's say, and this is center C1. This is C2. So what is the distance C1? R minus R1, right? This whole distance is R, right? The distance of the center to the circumference, this is equal to R, and this distance is R1, right? So therefore, C1 is equal to R minus R1. And what is C2? R plus R2, right? So what do we need to do to eliminate R from here? Subtract these two equations. So I'll get CC2 CC1 is equal to R2 plus R1. So this is again an hyperbola. The similar questions can be asked, like both the circles can be inside, both the circles outside, one inside, one outside, right? Understood?
Can we trace the axis using
Can we?
can we trace the axis of hyperbola?
Yeah, we can. So this is the center, right? So the point will be, now these two are the foci. So the line joining the foci will be the axis. So this will be the axis, right? So perpendicular to the axis, right? Passing through the midpoint, we'll get directrix, the conjugate axis. Now this will be the axis containing the foci, and this will be the conjugate axis. It is always perpendicular, right? So the hyperbola will go like this, and similarly we can get the other branch like this, somewhere like this. Okay, understood? So next, write down a line and a hyperbola. So this is the next topic. A line and a hyperbola. So we have the hyperbola, which is x square upon a square minus y square upon b square is equal to 1, and we have the line y is equal to mx plus c. So can you find the condition where this line will be tangent to the hyperbola? Can you find the value of c here? We used to find the value of c for the case of circle, parabola, ellipse. Do you remember all the values? The value of c for the case of circle was a root 1 plus m square plus with a plus minus sign. For the parabola it was y is equal to mx plus a by m. Ellipse? Yeah. So try to derive it here. So we will put the value of y in here. So we'll get b square x square minus a square y square. So I'm putting the value of y here. Mx plus c square is equal to a square b square. Okay. If you expand this, you will get b square minus a square m square into x square. Okay. Plus 2a square, no, minus 2a square mc x minus a square c square minus a square b square is equal to 0. So everybody is getting this? Okay. If this line is touching this hyperbola, if I try to find out the points of intersection, how many point of intersection will I get? This line is just touching the hyperbola. It's tangent. Just 1 point. So the condition for tangency will be that this quadratic equation will have only one root, because this is just touching, not intersecting, right? So the d for this equation will be 0. So what is the discriminant here? It will be 4 a to the power 4, yes, plus 4 times b square minus a square m square into a square into b square plus c square. So this is what you'll get, right? So what you need to do is b square minus 4ac, right? That's how we find the discriminant. So from here we can cancel 4 and 4. We can cancel this a square, right? And we'll get a power 2 here. What are you getting? Tell me the final result. So on expanding, we'll get a square c square m square plus b to the power 4 plus b square c square minus a square b square m square is equal to 0. This cancel out, right? So we can cancel b square as well from here. So we'll get b square c square is equal to a square b square m square minus b to the power 4. Is this visible? So finally what you're getting is b square c square is equal to a square m square b square minus b square c square. You can cancel b squares from here. Okay, this is b to the power 4, sorry. So I'll get 2 here. So I'm getting c square is equal to a square m square minus b square. So the value of c here will be plus minus root a square m square minus b square. Yes? Yeah, exactly. So instead of plus b square, which we used to get in ellipse, we are getting minus b square here. Okay. So finally we can say that equation of tangent in slope form. Why is this called slope form? Because in the equation we are getting m over here, right? So that is the slope. So we will get y is equal to mx plus minus root a square m square minus b square. Okay. So write down a question. Find the equation of the tangent to the curve. Find the equation of the tangent to the curve 4x square minus 9y square is equal to 1. That are parallel to 4y is equal to 5x plus 7. Find the equation of the tangents to this hyperbola that are parallel to this curve. So this is a straight line, right? What is the slope of this straight line? 5 by 4. You just divide whole equation by 4. You will get y is equal to mx plus c form. There m will be equal to 5 by 4. Okay. And what is the equation of the tangent of this? So just find out a here, b here, right? Find the value of a square, b square, and you know m square, right? Just put it in the equation. We'll get two equation of tangents. What is the answer?
Y equals to 5 by 4x plus minus under root of 161 by 576.
Under root
161 by 576.
576 का भी under root.
24.
That is 24 here.
वो तो पापा 161 था ना इसलिए.
Oh, okay. Done. So if you convert it into standard form, you will get x square upon 1 by 4 minus y square upon 1 by 9. So this will be the first step, right? So the value of a square is, b square is, m is 5 by 4. Just put the values. You will get y is equal to 5 by 4 x plus minus square root of into 25 by 16. So y is equal to 5 upon 4x plus minus 161 upon 576. Okay. So this will be 24. So you'll get 24y is equal to 30x plus minus root 161. So this will be the answer. Okay. Okay. So next we'll discuss the equation of tangent in the parametric form. So remember what was parametric form? Okay. Let's discuss both Cartesian form and parametric form. So I explained you last time. What do we mean by the Cartesian form? When we have the equation in x1 and y1, right? And what do we mean by parametric form? When we use the parameter, in this case the parameter will be theta, right? What are the parametric coordinates? A secant theta, b tan theta, right? So we have x square upon a square minus y square upon b square is equal to 1. So the equation in Cartesian form will be x1 upon a square upon b square is equal to 1, and the equation in parametric form will be, so we'll put the value of x1 is equal to a secant theta and y1 is b tan theta. So finally we'll get x secant theta upon a y tan theta upon b is equal to 1. This is the final answer. So these are the equation of tangent in Cartesian form, parametric form. So we have done all these equations, right? Equation of tangent in all these forms, in all the curves, right? So what I need you to do is, when you go at home, prepare a table. Okay, in that table write down circle, right, parabola, ellipse and hyperbola, and write down all the equations and all the necessary things, right, like this. First we write down the tangent in slope form. Okay, if you want we can make the table right now. What do you want? Right. Okay, so let's do it then. Are we left with anything? I think we should do the normal first in this case, then we'll do. So how will you find the equation of normal?
Finding the slope minus 1. Slope and 1 upon multiplication of tangent. Slopes of tangent and normal will be minus 1.
Yeah, slopes of tangent and normal will be minus 1, right? So we have x1 upon a square minus y1 upon b square is equal to 1. This is the Cartesian form, and the parametric form is x secant theta minus y tan theta upon b is equal to 1, right? So what is the equation of what is the slope of tangent from here? Slope of tangent will be b square x1 upon a square y1. So what is the slope? Minus the coefficient of x upon the coefficient of y. So coefficient of x is x1 upon a square. Coefficient of y is y1 upon b square with a negative sign, right? We already had a negative sign, so that's why it cancelled. So what is the slope of the normal then? Slope of the normal will be minus a square y1 upon b square x1. Okay. Okay. So we'll come to this later. And in this case, what do we have? So just put the value of y1 and x1. Okay. So here the slope will be equal to minus a tan theta upon b secant theta. Right? So can you find the equations now? So equation in this case will be y minus y1 upon x minus x1 is equal to minus a square y1 b square x1. And in this case, y minus b tan theta x minus a secant theta minus a tan theta b secant theta. Right? So solve it from this. So finally, rearranging and making it a nice term. So you will get a square x upon x1 plus b square y upon y1 is equal to a square x upon x1 plus b square y upon y1 is equal to a square plus b square. And similarly in this case, just put the value of x1 and y1. So you will get a x. So this will be sec theta. 1 upon sec theta is cos theta. So ax cos theta plus by cot theta right? Just put the value of x1 and y1 is equal to a secant theta and b cot theta, b tan theta. Okay. So remember any of the relations. So yeah, why do we get secant theta and tan theta as the parameters? Because here we have the equations as x square minus upon a square minus y square upon b square is equal to 1. Okay, we discussed this last time. Now what I need to do is, instead of using two parameters here, I need to introduce only one parameter, right? So that I will form simpler equations and I will need minimum number of equations here, right? For that thing, I will have to use trigonometry over here, right? Difference of two squares is equal to 1. What trigonometric identity is this one? Secant square theta minus tan square theta is equal to 1, right? So if we equate x upon a is equal to secant theta, right? So if we compare these two, I will get x upon a is equal to secant theta and y upon b is equal to tan theta. So therefore x is equal to a secant, cot and cosecant and cot, yeah, you can use. Okay, so this is what we'll get. But in that case, if you use cosecant and cot, the coordinates will differ a little. Okay, here we have the coordinates with respect to the auxiliary circle. In that case, we'll have some difference, I think. Like at 30 degrees, what is the value of secant theta? It will be 2 by root 3, and the value of cosecant theta will be 2. Yeah, the coordinates will differ in that case. Yeah, the focus and everything will be same. Overall, the equation won't make any difference, right? We will be able to solve your questions, but prefer this one, secant theta and tan theta. Okay. Other way of seeing this is, let's suppose these are the two branches of hyperbola. This is auxiliary circle. This is angle theta over here, right? So which point will be represented by A secant theta, B tan theta? Any idea? If this value is A, can you find the value of A secant theta and A tan theta? Yes? How? This line. So if you draw this line, you won't be able to plot points on this hyperbola. Yeah, you can do that, but I'm saying if you make this triangle, right? That's what you're saying. You won't be able to get points on this hyperbola. You will be able to get points here or there somewhere. Yes? Yeah, exactly. So what we'll do here is, at this point P, we can draw a tangent like this. Okay. These two angles are, this angle is 90 degree, right? This angle is theta, and this is A. Can you tell me what is this distance? So let's say this is O, this is S. So OS upon OP is equal to what? Or let's say OP upon OS, because OS is the hypotenuse, is equal to cos theta. So therefore OS is equal to OP secant theta. So this is equal to A secant theta. So this is a coordinate of this point, x coordinate of this point. Okay. Now figure out how will you get the y coordinate here. You need to find this coordinate, y coordinate. Where do you have B over here? Let's say B is somewhere over here. Okay. Now the other coordinate should come as B tan theta, right? So if we extend the tangent, then this angle, where is B? This one. Okay. So this angle POB will be 90 minus theta. Okay, good. So this, then what? Okay. So this whole length will be, let's say, B. Okay. And this angle is 90 minus theta. So what do I need to find here? I need to find the y coordinate of this, which is this side. This is the y coordinate, this will be the x coordinate, this is the y coordinate, right? So let's say this is the point x or t. Then what do we have here? So we'll get if I draw a line joining these two, B, am I getting anything? वैल्यू y कोऑर्डिनेट की BOS triangle. Okay, then This is 90 minus theta. But we don't know that this tangent is passing through this point B or not. It can pass, it cannot pass. So let's try to figure out from here. Let's say this is B. Okay. And I'll complete a triangle like this. Somewhat like this. And let's say this is some point R. So I have a triangle OBR. This angle is 90 degree. This is B. But I won't get tan theta from here. For tan theta, OPS. But I need to introduce B as well as tan theta. So how can we do that is, if we take this thing, right? Some triangle like this. So I will get this as 90 minus theta, and let's say this is 90 degrees. Then in this case, OB upon, let's say this is some other R. So OB upon RB, this will be equal to cot 90 minus theta, tan theta, right? So OB is equal to RB tan theta. No, we're not getting. Okay, we'll see this later. This one later. Okay, we'll have to figure out. It will take time. So what is the next question? If the vertex 2, 3, to find the equation of what? Okay, yeah. So whenever we have x square upon a y x square upon a square minus y square upon b square is equal to 1, right? So if we shift the vertex 2, 3, we're shifting the vertex. That will be when we shift the center, right? So I think this is incomplete data. We need to know something else as well, right? So if we know the value of A or we know the value of B, then we can figure it out. Like if this is a point 2, 3, and this is a vertex, right? I need to know the other vertex, right? If this were the center, if the center was 2, 3, then it would be easy. Then it would be x minus 2 whole square is equal to 1. So I think if the specific data is given, then we can see the question. So let's form the table now, right? So first we'll have a so here we'll have circle, parabola, ellipse, hyperbola. Okay, so we all know the equations, that we don't need to write. Next thing, the first thing which we need to write is the equation of the tangent. B tan theta can be found using the standard equation of the hyperbola. Yeah, from the standard equation we saw that thing, that whenever we have x square upon a square minus y square upon b square is equal to 1, it resembles secant square theta minus tan square theta is equal to 1. That's how we did that. But we were trying to prove it geometrically, right? We'll see that later. So for the tangent, in the case of circle, whenever we have tangent in slope form, it will be y is equal to mx plus minus a root 1 plus m square. In the case of parabola, mx plus a by m. For ellipse, root plus b square. For hyperbola, a square m square minus b square. Right? Now Cartesian form we can figure out. So that is very easy. For the Cartesian form, just replace x square with x1, y square with y1, you will do it. Right? Next, let's see the parametric coordinates. So in the case of circle, we have a cos theta, a sin theta. Here we have, what will be the parametric in case of parabola? 80 square comma 280. Good. 80 square comma 280. In the case of ellipse, a cos theta, b sin theta, and here we have a secant theta, b tan theta. Okay. The next thing will be director circle. Here the director circle will be x square plus y square is equal to 2a square. In the case of circle, it is x square plus y square is equal to 2a square. In the case of parabola, this is directrix. Equation of directrix is x is equal to minus a. In this case, it is and in the case of hyperbola, it is with a minus sign. Right? Next, equation of the normals. So let's suppose you need to find the equation of normal at the coordinate x1, y1 or at the parameter, right? How will you find the equation of normal for a circle? That will be radius, right? But how will you find the equation then? Like let's suppose you're given a point on the circle and you need to find the normal there. So one thing is you can find the equation of the tangent and take the perpendicular. What is the other simpler way? Anyone? Yeah, exactly. So for the normal, we have this point and we have the center. Since tangent and normal are perpendicular, also in the case of circle, the radius and the tangent are perpendicular. Therefore, the normal will be the radius. It will passing through the center. So we know the center here, right? Let's say this is minus g, minus f, and this point is x1, y1. Can you find the equation now? X minus x1, y minus y1 upon x minus x1 is equal to y1 plus f upon x1 plus g. So you get y minus y1 upon x minus x1 is equal to y1 plus f upon x1 plus g. Equation of normal in the case of parabola. It will be y is equal to minus tx plus 2at plus at cube. Remember? We studied this thing. Or this can be y is equal to mx minus 2am and after this we did that thing that from a fixed point we can draw three normals. From a point inside the Parabola, we can draw 3 different norms. Yes.
So in case of this circle,
Yes.
right hand side is slope we are considering.
Yeah, this one is a slope. Y minus, this is the 2-point form of the equation of the line. So in the 2-point form, we have y minus y1 upon x minus x1 is equal to y2 minus y1 upon x2 minus x1. Right? In the case of ellipse, ellipse, find it out, say it. What's the equation of normal in the case of ellipse? Yeah, I think we simplified this thing further. Is equal to a square minus b square sine theta cos theta. So we have ax sine theta minus by cos theta is equal to a square minus b square sine theta cos theta. This t is the parametric coordinate. This t is the parameter which we have. Like in the case of parabola, we have the equation like this: y square is equal to 4ax. So we cannot possibly use any trigonometric relation here, right? In the case of circle, we could use it because it was x square plus y square is equal to 1. Here we have one term of y square and the other term of x. So we cannot possibly use any trigonometric expression. That's why we need to take the help of this parameter t, right? We can also use the parameter of exponential, but that's unnecessary, right? In your syllabus, you have this parameter, which is t. The parametric coordinate will be 80 square comma 280 because they fit in this, right? If you put the value of 80 square here, x is equal to 80 square, the value of y will be equal to 280, right? And the case of normal, in hyperbola, we just did this, right? So I think you can write it now, right? So what was the equation? A square plus b square. So ax cos theta plus by sin theta is equal to. So we have just done some parts. Do the rest of the things, all the results you can remember of at your home, right? Complete this table and then memorize all the results. That's very important. Any doubts still here? No? Okay. So if you're not able to read it, I'll repeat these things. Y is equal to mx plus minus a root 1 plus m square. This is y is equal to mx plus a by m. Y is equal to mx plus minus root a square m square plus b square. Y is equal to mx plus minus root a square m square minus b square. Parametric coordinates are a cos theta, a cos theta, a sin theta. Here we have 80 square 280, a cos theta, b sin theta, a secant theta, b tan theta. For director circle, in the case of circle, x square plus y square is equal to 2a square. In this case, we have equation of directrix, which is x is equal to minus a. X square plus y square is equal to a square plus b square. Here we have x square plus y square is equal to a square minus b square. For the normal of a circle, you know the point and you also know the center, right? So just join the point and the center. The line joining the point and the center will be the normal, right? So I just wrote this equation in 2-point form. Y minus y1 upon x minus x1 is equal to y1 plus f upon x1 plus g, where minus g comma minus f are the coordinates of the center. For the parabola, y is equal to minus tx plus 2at plus 80 cube, or if you want to see it in the slope form, y is equal to mx minus 2am minus am cube. Ax sin theta minus by cos theta is equal to a square minus b square sin theta into cos theta. And here we have ax cos theta plus by cot theta is equal to a square plus b square. So write down the next topic. Yes. What equation of diameter? Yeah, it will be same. What is the equation of diameter? That is the equation of circle in diametric form. That is not the equation of diameter. Okay. Understood? Next heading, write down a rectangular hyperbola. So do you have any idea? What is a rectangular hyperbola? Yeah, good. So leave some space after this. Okay, don't start it from here. Leave a page so that you can complete the table then. So in the case of rectangular hyperbola, we have x square upon a square minus y square upon b square is equal to 1, let's say. For rectangular hyperbola, a will be equal to b. Okay. So therefore, the equation will get reduced to minus y square is equal to. Okay. If I did the same thing for ellipse, what would happen? It would become a, what is that? A circle. If we did the same thing for the case of ellipse, it would become a circle. So whenever we have x square plus y square is equal to a square, that is the equation of the circle, right? But in the case of hyperbola, it will stay a hyperbola, right? But it will become a rectangular hyperbola, right? So what is the eccentricity in this case? 1 plus a square upon a square, because both the values of b square and a square are same. So I will get square root of 2. Okay. So this is a rectangular hyperbola. And what will be the conjugate of this hyperbola? So conjugate will be x square minus y square is equal to minus a square. So we just multiply the whole equation with this side with negative sign, right? Or you can write this as y square minus x square is equal to a square. Same thing, right? In the case of standard hyperbola, whenever this was the hyperbola, the conjugate would be x square upon a square minus y square upon b square is equal to minus 1. Written. So if we try to plot this hyperbola, rectangular hyperbola, let's see what I'm getting. So we have x square minus y square is equal to a square. Okay. So this will be a hyperbola like this. This is a length a, and this is also a. So what we do in this case is we try to rotate this hyperbola such that, yes, it forms a rectangle, that this branch comes inside this first quadrant. Okay. Now imagine it is going like this. Okay. What if I rotate it and bring it over here? It will become something like this. Can you imagine this thing? If I rotate this thing by 45 degrees, okay, now this is a axis right now. If I rotate this axis like this, okay, by 45 degrees anti-clockwise, I will get two branches like this. So this is the first branch, this will be the second branch. Okay, and we'll have to apply the rotation of axis here. So finally the result which we get is that the hyperbola will be converted into this equation, xy is equal to c square. Okay. So this hyperbola x square plus y square is equal to a square, right? This will be converted into xy is equal to c square. C is some other variable, like we have a square over here, this is c square. Okay, we'll discuss c this later. Okay, now just try to imagine this thing. In this case, okay, just write this down first, then I'll explain. Have you studied asymptotes? No? So just remember these two things first, that the standard rectangular hyperbola is given by x square minus y square is equal to a square, right? But if I tilt it by 45 degrees angle, it will be xy is equal to c square, and it looks like this then, right? So first let's study asymptotes, and then we can merge all the things up. So what is an asymptote? Write down the definition. An asymptote, so this is the spelling. An asymptote is the line which is the line which is tangent to a given curve at infinity. Tangent to a given curve at infinity. Written this thing. So let's see, do you know a little bit of calculus? Do you know the graph of log x and e to the power x? I think you must have studied in this in functions. Haven't started. Okay, you know the graph of tan x? Everybody knows? So the graph goes like this. Right? So if you see at infinity, right, if you draw a tangent here at this curve, what will be the tangent then? This is pi by 2. If you draw a tangent at infinity, it will be parallel to the y-axis. The tangent will be this line, right? And similarly I have a tangent over here. So these lines will be said as the asymptotes to this given curve. This is the first example. Second example is y is equal to e to the power x. So the graph of e to the power x goes like this, right? Exponential growth, right? It starts increasing and gradually increase like this. So if you want to see the tangent at this point, at negative infinity, can you tell me what is the tangent at negative infinity here? It will be x-axis. Now this one is the x-axis, this is the center, right? Now parallel at negative infinity, the tangent will be this x-axis. We don't actually know this, but we can imagine this thing, right? Because the slope is falling down, right? Slope is very big here. It is falling down, becoming lesser, lesser, lesser. Eventually, at infinity, the slope will become 0. Yeah. So if the slope becomes 0, it will become an x-axis, right? So we can say that x-axis is the asymptote to e to the power x. Understood this thing? So what happens in the case of hyperbola? So imagine this is the given hyperbola. Now if you want to draw a tangent at any point, what you can do is take this point and draw a tangent. It's very easy. So can you tell me, can you figure this out? Can this tangent ever meet this curve? Can the tangent at this first branch ever meet this branch? Or can it be tangent to both the branches? Yes? Yes? In case of rectangular. Okay, can you find the equation of that tangent? Now see, I'll give you a hint. So these are the two branches. So for a line to be tangent to both the curves, both the branches at the same point, right? This is only possible in the case of asymptotes. Okay, no other case. So whenever I'll try to make a tangent over here, it will either intersect this curve, right? It will either go like this or it will not pass through this curve. But the only case it will be tangent to both the curves will be in the case of asymptotes, which means it will be only tangent at the infinity. So it will be tangent at this plus infinity and this minus infinity. Similarly here, minus infinity, and here, plus infinity. Now technically this is not tangent because it will never be touching, or maybe it is touching but we don't know that, right? So can you try to find the equation of these asymptotes here? If this is a standard rectangular hyperbola, x square minus y square is equal to a square, right? So can you try to see what will be the slope of this line? Okay. Okay, you can differentiate as well. Any other way? Now see, you need to find the slope, right? So the slope, either it can be found by differentiating. So let's cover that thing first. So we'll get 2x x1, 2x, let's say, minus 2y y dash or dy by dx is equal to 0. So value of y dash is x upon y, right? So both x and y are now tending to infinity, right? Because we have to see the tangent at the infinity, right? So if you put a limit over here, limit x and y both tending to infinity. So can you tell me what will be the value of x upon y? This will be equal to 1. Both are tending to infinity. Have you solved such limits? No. Infinity upon infinity form. If both are tending to infinity, right, and both have same powers, then it will become 1, right? So this slope will be equal to 1. Other way of seeing it is, since this is not touching, right, this hyperbola, therefore let's suppose this is a, then this length will also be equal to a, right? If this is not equal to a, then this will go cutting it, right? If this is greater than a, then it will go like this. It will not even pass. Now see, if this line is going like this and it is not touching the curve, not touching this hyperbola, this branch of the hyperbola, then if I see this distance, this is a, then this distance is also equal to a, right? If this distance is anything lesser than a, then this will go intersecting or cutting the hyperbola like this. Or if the distance is any greater than a, then this will not cut or not intersect the hyperbola at all. Okay, so therefore these two distances should be equal. Therefore both of these are a, right? So therefore the slope will be equal to 1, since this angle will be 45 degrees, right? So tan 45 will be equal to 1. So what you need to remember is that in this case, the asymptote will be this line, which is inclined at an angle 45 degrees, and the other line which is inclined at an angle 135 degrees with the x-axis, right? So if we try to find the equations here, the equations will be x minus y is equal to 0 and x plus y is equal to 0. Okay, since this line will be y is equal to mx and this is passing through 0 comma 0, so therefore this equation will be y is equal to 1x and the other equation will be y is equal to minus 1x. So these are the two equations. Now see, can you see any resemblance here? Like when you have the hyperbola x square minus y square is equal to a square, then these are the two asymptotes. Is there anything in common? This is asymptote 1, asymptote 2. This is a multiplication, right? X square minus y square. How do you get x square minus y square? By multiplicating these two. By multiplying these two, right? So if I have the combined equation of the asymptotes, the combined equation, have you studied pair of straight lines? Pair of straight lines. No, pair. No? Okay. So if you multiply these two equations, you will get x square minus y square is equal to 0. And this is the combined equation of the asymptotes. I mean, this is the combined equation means if you factorize this equation, right, you will get x plus y is equal to 0, x minus y is equal to 0, you get two straight lines, right? What is the conjugate of this hyperbola? X square minus y square is equal to minus a square, right? You can see here that this hyperbola and its conjugate, if you add these two equations, what you will get? Twice of the asymptotes. Okay, so this is what we need to remember, that whenever we have hyperbola and its conjugate, we add these two equations, we get twice the equation of the asymptotes, and this is nothing but the combined equation. So this is combined equation of asymptotes. Yeah. So how did we get 2x minus 5y dash? If we differentiate this thing, what is the differentiation of x square? X square differentiation is 2x. What is the differentiation of y square? It is 2y into dy by dx. So I just wrote dy by dx is equal to y dash. A square is a constant, right? Differentiation 0. So that's how we saw the term dy by dx is equal to x upon y. Okay. Understood? Now see. Now remember what we studied there. If I tilt the hyperbola by 45 degrees angle, right? So the line x plus y is equal to 0 and x minus y is equal to 0. Since these are the two asymptotes, right? This first asymptote, the second asymptote. So if I tilt this by 45 degrees, what will happen to the asymptotes? What are the new asymptotes now? X-axis and y-axis. Now the asymptotes will become x-axis and y-axis since I rotated this by 45 degrees angle, right? So this will be the two asymptotes. Therefore, my hyperbola will not ever cut these two asymptotes. These might touch the hyperbola at infinity. That's the definition of asymptotes, but it will never cut it. So the case of hyperbola xy is equal to c square will look like this. So this is the hyperbola xy is equal to c square. And how did we get this? By rotating these by 45 degrees. On 45 degrees rotation, this becomes x is equal to 0. On 45 degrees rotation, this becomes y is equal to 0. So this becomes the y-axis and the other one becomes the x-axis. Okay. Now this function is also known as the reciprocal function. Have you studied this thing? xy is equal to 1. This is actually y is equal to 1 by x. Right? So this is also known as the reciprocal function. If you put the value of x is equal to 2, you will get half. X is equal to 1 by 2, you will get 2. Okay. And the graph of the reciprocal function is always a hyperbola. So you get xy is equal to c square. In this case also you can see that as we had x square minus y square is equal to a square. The two asymptotes were actually the product of the two factors here, x plus y and x minus y. Here the two asymptotes will be x is equal to 0, y is equal to 0. Understood? The two asymptotes were x plus y is equal to 0, x minus y is equal to 0. Here they are, x is equal to 0 and y is equal to 0. Okay. So let's try a question here. Okay, one more thing. If you have x square upon a square minus y square upon b square is equal to 1. Can you find the asymptotes of this hyperbola? So what do we need to do is, we know this hyperbola, we know its conjugate. What is it? Is equal to minus 1. So what will be the equation of the asymptotes? 2 times the equation of asymptotes is equal to. So if you add these two equations, 1 and minus 1 will cancel out. So you will get x square upon a square is equal to 0. So this is twice the equation of the asymptotes. So the equation of the asymptote will be x square upon a square minus y square upon b square is equal to 0. So if you factorize this, you will get x upon a plus y upon b is equal to 0, x upon a minus y upon b is equal to 0. So the combined equation will be this: y is equal to b upon ax. Okay. So the slope of the asymptotes in this case will be equal to b upon a. Okay. This is very simple to remember. You can also remember this like this: that whenever we have the hyperbola, just take the slope as the ratio of b and a. So this will be the slope of the asymptote. Since this will not cut the hyperbola, and this is just touching the hyperbola at infinity, right? So therefore the slope will be equal to tan theta will be equal to b upon a. B upon a.
Sir, the slope of asymptotes will always be 1 while in
No, it won't be 1. It is 1 in the case of rectangular hyperbola. And in the case of rectangular hyperbola, b is equal to a. That's why we are getting 1 and minus 1. Right? Generally, this is plus minus b upon a.
so in other cases we will get asymptotes other than rectangular hyperbola.
Yeah, yeah. In this case also we are getting, right? So asymptotes are possible in case of each and every hyperbola. So write down question. Find the equation of hyperbola. Find the equation of hyperbola that has 3x minus 4y plus 7 and 4x plus 3y plus 1 as its asymptotes, and
Asymptotes passing through origin.
no, the hyperbola is passing through origin. So what is the combined equation of the asymptotes? It will be 3x minus 4y plus 7 multiplied by 4x plus 3y. So this is the combined equation of the asymptotes, right? Plus 7. So this is the combined equation of the asymptotes. We've seen in all the cases that the hyperbola, the conjugate hyperbola, and the asymptotes, they all have similar equations. They only differ in the constant terms, right? Remember, whenever we have x square upon a square minus y square upon b square is equal to plus 1, this is hyperbola. Conjugate will be minus 1 and asymptotes will be 0. Adding these two, right, and dividing by 2. So in the case of asymptotes, we'll get 0. So I know one thing, that all the values of x and y, all the coefficients of x square, y square, x and y, they will remain the same. Only the constant term will change. Okay. So in this case, if you multiply these two equations, so you will get, what are you getting? 12 x square minus 12 y square. You will get 9 terms, right? Plus 9xy minus 16xy minus 7xy. Okay. Plus 3x plus 28x plus 31x minus 4y plus 21y 17y minus 17y, no, plus 17y. And what is the constant term? Plus 7. Is this correct multiplication? Just check it out. Yeah, this is correct. So this is, yes, correct. So if you multiply all the terms, you will get 9 terms. Segregate them, you will get this thing. So in the case of asymptotes and the hyperbola, the only difference will be because of the constant term. So here the constant term is 7, right? He has given me one hint that the hyperbola passes through the origin. So the equation of hyperbola, we know that it will be of the form 12x square minus 12y square minus 7xy plus 31x plus 17y plus c, some other constant, right? The constant term will be different. Now if this passes to 0, 0, what is the value of c? How? So if this passes through the region, you will put the value of x and y both as 0. So this is 0 minus 0 minus 0 0 0 plus c is equal to 0. Since 0, 0 is satisfying, right? So the value of c will become 0. So this will be the case of hyperbola. Understood? We're putting x is equal to and y is equal to 0, both. Since this passes through the region, right? First of all, we wrote the equation of the asymptotes, right? Combined equation of the asymptotes by multiplying both the equations, both the equation of straight line. Now we know that the only difference between the asymptote, conjugate and the hyperbola is in their constant terms, right? So I took all the terms like this and I wrote this constant term as some C1, okay, like this. So if I wrote this as C1, now the next thing I know is that this hyperbola passes through the origin. So it passes through 0, 0. So I put 0, 0 in this whole equation. It will become 0. So therefore C1 is equal to 0, right? Now next step, can you find the equation of the conjugate hyperbola here? Do it. So this is the equation of hyperbola. We'll get no constant term here. What is the equation of conjugate hyperbola? Same. No. We wrote one formula. H plus C is equal to 2A. Apply that formula. Right? So all these terms will be same. Only the constant terms will differ.
Plus 14.
Plus 14. Good. So in the case of conjugate hyperbola, we'll get 12x square minus 12y square minus 7xy plus 31x plus 17y plus, let's say, c, some c. Okay. So we know that h plus c is equal to 2a. So therefore if I add these two, I will get c plus 0, right? And this is becoming twice, is equal to 2a. If I multiply this by 2, I'll get 14 here. Therefore the value of c will be 14. So this is the equation of the conjugate hyperbola. Understood? Now the next concept is to find the angle between the two asymptotes. So if you have x square upon a square minus y square upon b square is equal to 1. Now this will be your homework. And try to do it this time. Okay. So we get two asymptotes, one going like this, passing through the center, and the other one like this. So what you need to do here is find the, correct answer. You need to find the angle between these asymptotes. Okay. So find the angle between the two asymptotes. Always. Yeah. So in the general case, find the angle between the two asymptotes. Okay. This is your homework. And try to prove the result that if this angle is 2 theta, then secant theta is equal to E. If this whole angle is 2 theta, then secant theta should be equal to E. Okay. Or you can say if this angle is 2 theta. Okay. So we'll discuss this next time. Try to prove this thing. Okay. Thank you.